This is a robot that should be familiar to many people. This is a vacuum cleaner robot.
You're right.
Yeah.
Actually, it's part of it. Like the base is the vacuum cleaner, but what we put on top is much more sophisticated sensory stuff. Like we have a camera, we have a laser scanner,
right.
we have an onboard computer. So it's basically we're just using the base to move around, and the rest is all ours here. So
well, that's excellent. So this is like a simple laptop camera. I recognize.
This is a simple laptop camera, and it's 30 hertz. So we can get like all the kind of stuff.
Yeah. Oh yeah. Okay. So I'm waving my hand in front of it. It's showing up there.
That's right.
And what's the purpose of having this extra attachment on top of that?
Yeah. So I'm not interested in vacuum cleaning. So my problem that I'm looking at is if you have a bunch of robots in the world, that can be any sort of robot, could be an XE robot, could be one of these. How do you coordinate teams of robots? So I'm interested in multi-agent teaming, planning for multiple robots under uncertainty. So the example that my PhD is looking at is a military-funded project. So if you have some sort of attack or natural disaster and there's like victims scattered in the world, how do you make sure that you can plan efficiently for teams of robots? Okay,
so this would be optimizing the response of the robots, so they're not acting as individual elements.
Exactly, that's absolutely right. Because you can imagine if we have like sophisticated robots that can put out fires, for example, there's a lot of scenarios where they have to collaborate.
Right.
Other times where they can go off individually and explore the environment. So there's like a trade-off, some sort of optimization problem.
Okay.
How do you plan in like large, uncertain areas or spaces? So that's my interest.
Now, with these particular robots, these are cleaning robots.
Right.
I mean, if they had to clean up this area, you could coordinate their actions better.
Exactly.
Is that already happening?
So it's not happening in industry. The iRobot Roombas, they are not team-based robots. So they're all individual robots. They have their individual bases. And there is, as you said, there's a huge potential, like in all kinds of applications.
Right.
Like military, for example, how do you coordinate teams of drones that are right now like supervised, like independent? Cleaning robots, like how do you divide up the space, etc. And like rescue type of scenarios that I'm looking at. So.
Now in terms, I mean, could you hook these up to program them to kind of coordinate their actions, or you're looking more on the military side specifically?
Well, so the only reason why I'm doing that is because my money is actually coming from the military.
Okay.
That's why I have to mention it. But so for my PhD, it's going to be a simpler scenario. There's going to be like a big space. Probably I'm going to scatter some sort of Barbie dolls in the environment. And then my goal is going to be to show that if these robots cooperate and work together, that they're going to find all victims in the space like quicker than if they all like were doing the individual kind of policies and plans and stuff like that.
Okay.
So that's kind of the toy example that I'm looking at.
Well, that sounds very interesting. I mean, the linear optimization thing, I've learned about that recently.
So that comes into that. There's more stuff like Markov decision processes, which basically take the uncertainty into account. Like because these robots, if you bump into something, they lose their localization. They don't know exactly where they are.
Right.
So there's a whole bunch of techniques that take into account this kind of sensor and uncertainty for these kind of systems.
Okay. Well, thank you so much for taking the time to explain this. It looks really interesting. Okay. Another cool robotic thing going on. This looks more like an art project. And that's Cynthia Brazil, who's actually one of the big robot researchers here. I've seen her on TV before. But I think I'm going to sign off right now because I'm running out of space on my iPod, and this is a pretty long video. I don't even know if YouTube will accept it. But this is the Media Lab. This is the cool stuff that... Well, that's just a conference room, but this is some of the cool stuff that goes on. Lots of different projects, lots of interesting applications. And... it's MIT, and it's kind of like you open every door and something else really cool is going on, and it's neat to be able to see some of that, even a tray of kind of unused machines. Ian Lamont, Sloan Television Blog, signing off.